welcome. Welcome to this talk. My name is Claus Ibsen, and I'm here to talk about Camel Microservice with Spring Boot and Kubernetes. I gave this talk 2 days ago in Milano in Italy, and I got the thumbs up from the Italian guys. But let's see how it goes here. Maybe you guys are harder to fool. This is my first time here in Switzerland, or it's our first time. I'm traveling together with my friend here. This is Mr. Camel. He's sort of like a mascot or a spirit animal for the project. So we go around, giving talks and spread information about Camel and give a little Camel love. He's a bit different mind than myself. He's sort of like a grumpy camel. He likes to drink and whatnot, so just be a bit careful. So I am a software engineer from Red Hat. I've been working 10 years on Apache Camel as a full-time committer. I wrote 2 books on Camel, and I'm based in Denmark. Some people mistake me as a Swede because I've been living 10 years in Sweden, and most of the time I was there, I worked on Camel. But I'm back in my home country in Denmark, nearby my mother and father, so they are pleased. I put some contact details. You feel free to reach out to me. So what is Camel and what do you use it for? Anybody here has been using Camel or are using Camel? So in the audience for the video, there's maybe 10 hands or so. So that's good. There's still a lot of people that don't know what Camel is, and you are in the right room at least. So what I would like to do is to introduce you to Camel, to say a bit about what you use Camel for. So you use Camel for system integration or integration. So Camel is that piece of software that sits between the IT systems and connect them together. Now, if we are defining what Camel is, there are 2 words. It's an integration framework, and it's based on enterprise integration patterns. So let's take a closer look at those 2, starting with integration framework. I like to picture Apache Camel as a toolbox that has ready-made tools for you as a Java developer to use to build your integration. So you can focus at a higher level about the business problem and the integration problem. And then Camel takes care of all the lower-level details, so you don't need to write that. But what is enterprise integration patterns? Well, that's in fact a book with that same title. So the authors of the book, Gregor Hobby and Bobby Wolf, were consultants that went around from client to help them in integration. And what they saw was the same problems occurring over and over again. So what they did was to write down notes about these problems and how to solve them. And then over time, they got a lot of notes. And then they thought, okay, maybe we can, formalize these notes into a book. And thank God they did that. Now, this book is published 13 years ago. So it's a special book. Maybe some of you guys know the Gang of 4 book, which is sort of like design patterns for programming. This is a design patterns book for integration. In the integration world, we call this the Integration Bible. This book is actually a rare IT book because it's still valid today. So if you go and purchase the book and read it, the information is still good. That is not something that happens too often in IT books. Now, in this book, we have design patterns, or you can also say recipes, how to solve common integration problems. Here on the slides are some of them. Maybe the most famous one is called the content-based router. It's sort of like an EFLs in Java, but you can also filter messages, you can dynamic route messages, you can send a message to a number of recipients, you can split and you can aggregate, and so on and so on. But that is a book, and Apache Camel is a software, so what can you do? How does Camel apply to these patterns? So the idea of a Camel is that you can define how systems are integrated using Camel routes, or integration flow, if that's a better word for you. So the idea is you can use these patterns. So here are very basic Camel routes. So we are just integrating 2 systems straight without any patterns or message transformation, whatever. So we just say from file to JMS and send the message to a queue. 2 lines of code, and in Camel, you can define how these routes are built using Java code, which we call a Java DSL. or you can use XML, the XML DSL. So when we say DSL, we mean a domain-specific language. It's sort of like a mini language, but where you use enterprise patterns and so on. So it's a very natural language. There's no, in Camel, there's no alternative language, just straight Java or XML. So there's no magic there. Also, pay attention how it's a high-level abstraction. I said Camel was this toolbox with ready-made tools that allows you to focus at a high level, which you've done here. You just write these 2 lines of code. You don't write any code how to scan for new files and pick up new files when they're ready. You don't write any code how to connect to a message broker to send a message to it and so on. So that's a very high-level abstraction. Now, just a bit more, bigger example. This is quite still a common thing in integration is to exchange data using files. And it's very common to have the need for splitting a file line by line and then maybe do some message transformation. In this example, we are saying we are transforming from a custom format, a custom in-house format to XML, and then taking that XML message to send to a message broker called ActiveMQ, where you can further process that message. So if you use the Enterprise Patterns book, you can find these patterns in the book. There are 4 patterns. You can illustrate them, for example, on a whiteboard. But what we like to do as well is to write down using English words, or as the Camel route. So you can say from file inbox, now I want to split the message. I want to split the message body using a tokenizer, and the tokenizer is the new line character. Then I need to do a message transformation or a marshal. So I want to do a marshalling from some sort of custom format to XML. This is where you write your own code, because this is a custom in-house format. It's not an industry standard. Now, if it were an industry standard, then Camel comes with out-of-the-box transformation for that, for example, in finance and healthcare and so on. And then the last line is just to send the message to a message broker. So you have 4 patterns illustrated in the top, and that maps to 4 lines of code as well. It doesn't do that always, but in this example it does. So what about the Camel architecture? What is that you need to know about Camel? So this is the only illustration we need to know. So in the center we have Camel context. So what is Camel context? Well, Camel context is Camel. It's the runtime Camel. The idea is that you have this Camel context, then you can add a number of routes to it. And in these routes, you can use these enterprise patterns where you can use routing, transformation, validation, call custom business logic, and so on and so on. Then on the bottom, you have Camel components, which are used to connect to other systems, or as I say, to speak to the outside world. That's it. That is Camel. But where can you use and run Camel? Frankly, I would say Camel, you can use it everywhere. Well, that's a little lie. You can use it where you can use Java. Camel is a Java-based, so where you can run a JVM, you can run Camel. It's just a library. It's just some jar files you boot up to embed together with the application or so on. Now, Camel was created 11 years ago. So 11 years ago, the world of cloud and containers and whatnot was not really known to mankind. Back then, the application servers of the world were sort of ruling. So you were using maybe Oracle, IBM, JBoss, Tomcat, or whatnot. So back then, we built WAR files with our applications, and Camel worked beautiful there. But in the modern time, with containers, Camel also works beautiful there, so it can adapt to both worlds. What I'm trying to say to you is that there's no limitation where you can run Camel, so to speak. It's not tied to a specific app server or containers only. Now, Camel can connect to many different systems. Over the 11 years or so, we added a lot of components, as we call them in Camel. There are more than 200. On the slide, I'm trying to categorize them into 4 different things. You have the traditional enterprise system, file-based, socket, messaging, databases, and so on. Then you also have the public cloud vendors, the 3 big ones, Amazon, Google, and Microsoft. And then you have these online services, Facebook, Salesforce, ServiceNow, SAP, and others. And there's a constant battle. More and more online services are emerging on the scene, and we in the Camel community are catching up and building new components for those as well. Then on the corner here, we have IoT. This is an area you may not suspect that Camel works with. For example, I have a smartwatch. You may think, okay, Claus, are you really running Camel on this smartwatch? Sorry, no, of course not. Camel is not running on these small embedded devices like beacons and whatnot, sensors and so on. But in the IT world, it's quite common to have sort of like a gateway in between those sensors and then a backend system. Then the gateway is sort of like a microprocessor, but still powerful enough to run Java. And then it can make sense to add Camel in between, because Camel can bridge those two worlds. It has protocols for those lightweight embedded devices like MQTT and COPE. And then you can use alternative protocols to relay those messages to a backend system using AMQP or something like that. So we see Camel used in all these areas quite a lot. And it's still around Camel 11 years and so it's doing something well. It's also used here in some Swiss companies. So to summarize Camel, maybe using pictures, this is that framework, that toolbox with integration tools. Then you go and use these design patterns, came from the book. Then you define those and build your solution using Camel routes. And then you use these components to connect to all the different systems. And all together, that is Camel. Okay, so let's change topic a little bit. What about running Camel in the cloud? Maybe the illustration is a bit too dark, but there is actually a cloud here. And I like the shape of the cloud. It looks like a camel. So that's why I'm saying in the cloud. But when I'm saying in the cloud, I'm actually referring to running Camel on containers or Kubernetes. Yes, you can run that in the cloud, but you can also run that on-premise in your data center. And they are both with a C. And C is a beautiful letter, like my C in my name. And Camel. So maybe C is my favorite letter. Okay, so when we start to build and run our applications as containers, we are starting to moving away from building bigger monolithic applications to a more microservice architecture style. We split up these bigger applications into smaller pieces, known as microservices. Then over time, these microservices become more and more independent. They become distributed and networked. And now we have a different situation, which is called distributed computing. And as everybody knows, distributed computing is really hard. Now our services are split across in the cluster. They're running on maybe different JVMs, on different containers, on different hosts, and they communicate over the road network, and all things can go bad and wrong. And also, how do you manage and run that, And so why are we doing this instead of just having bigger applications as the monoliths? Well, if we need to run our microservice as containers with success, we need some help. So you as a developer don't need to write everything yourself or take care of all of that. We need an extra set of capabilities, or as I say, microservice-ilities. Yay, that's a new buzzword. So what we have here on the slide is some of those, or the ones I think. It's a shape of 10. So it's a decagon. So where do we get these services from, or capabilities from? Well, we get many of them from the container platform like Kubernetes. So Kubernetes makes it very easy for service or to discover service in the cluster. Kubernetes makes it easy to invoke service between the microservice. Kubernetes is certainly a dynamic platform that can scale up and scale down, so we have elastic. And also, Kubernetes come with primitives for around resilience to be highly available and so on. But there are other features that a typical enterprise developer will need, or enterprise company will need. And those are known as platform as a service, a PaaS. For example, it's very common to have sort of like a CI/CD solution in your enterprises. So developers can, build applications that can run through a pipeline in the CI/CD servers. So you can move your application from different environments, you can test them and so on. And then get them deployed into the cluster as well. You also need a way of being able to have gather logging, centralized logging, and also for operations team to monitor all these microservices in the cluster and so on. Also in recent time, there is a new term emerged on the scene, service mesh. and now they're talking about a cloud mesh. But one of the products that is standing out from the crowd there is called Istio. How many here in the crowd knows about Istio? Okay, so for the video recording, that's maybe 5 hands, so there's good opportunity to give talks about Istio. So Istio tries to be a solution for managing and connecting your service in a more fault-tolerant and secure way. So it has features around resilience and authentication and security, and also related a bit to distributed tracing and so on. When you start to have a lot of microservices with APIs, then you would like to look at some sort of API management solution so you can govern them. So your developers will be able to go to some sort of API registry to discover which APIs are there. They should be able to read about these APIs in a human way. There should also, of course, also be API contracts that are, for computers, like a Swagger doc and so on. And maybe, APIs are, you need some sort of user management around them. So to access the APIs, you may want to be able to only hand out API tokens. So, who have access control to those APIs. You may have different policies around service levels. So you may have, gold level and silver level and bronze level and so on. And you may want those users to be able to self-sign up and revoke API tokens and all that kind of thing. And that is quite a lot of things to manage. So it can be an idea to look for an API management solution when you have a lot of APIs. But this is a Camel talk. So where is Camel? So where is this guy? There's no Camel logo on the slide, and where is he? Well, if you play darts, you hit it in the center, it's like a bullseye. So Camel is in the center, it's with your service. So Camel is embedded together with your service, and Camel requires Java, so you can only use Camel with the Java-based service. So on the slide is with Spring Boot, Wi-Fi Swarm, or Vertex, etc. Those are Java technologies, but you cannot use Camel with Go or Node, sadly. But it's there in the center. So when we have distributed computing, and when you start to do a bit of integration, you can say you're doing distributed integration. So the idea with Camel is that it's not like a golden hammer. Everything is a nail, so use Camel everywhere. No, only use Camel where it makes sense. So if you have some integration needs in your service, then it may make sense to use Camel. So on the slide here, we have 3 services, and only A and C had integration needs, so we're using Camel there. For example, service C, it might be quite common for you have a requirement to be able to invoke a service outside the cluster from an external system. That system may be a legacy system, maybe a database, like an Oracle database or something like that. Now, Camel comes with 200 components, so there's a lot of connectors for that. And there certainly is connectors for connecting to a database using DBC or SQL or something like that. And then, it's quite easy for Java developers to use Camel to do that. So you just take integration where you need it, and only use Camel when you really need it, together with your service. So what are the practice for using Camel in the cloud on these containers? A good practice. Well, you should try to build your microservice in a small in size. Camel itself is lightweight. 4 megabytes, the Camel core is still lightweight. We are in the future for the next generation of Camel, Camel 3. We're going to split up the Camel core into smaller pieces, so it's going to be even lighter. But the intention is Camel, you just pick what you need, so take Camel core and these other components, and that's it. Then it's very popular to use this fat jar approach, where you bundle everything you need into a single deployment, a single jar, whatever, that has everything together. Spring Boot is certainly a pioneer in that area, but others can do that as well, like Wi-Fi Swarm, Vertex, and whatnot. And even, Camel doesn't require any of these. You can just run it as a public static void main application. Doesn't need any of that, if you don't need it. Your choice. You can also run it with Jetty, Mr. Jetty is here giving a talk as well. Another great practice around microservice and containers, or with Camel, for example, is to try to build your service as stateless. Those are much easier for the cluster and the container to manage. You can scale them easily up and down. If something goes wrong, you can respawn them and whatnot. But if you need state, Camel comes with components that can integrate with different states. Sort of like a memory grid or data grid using JBoss Finispan, Hazelcast, Apache Ignite, and others. And for persistent storage, you have for your typical SQL database, but Kafka and others are also in the mix, of course. But if you're running, stateful service on your cluster, like a message broker, Kafka, something like that, then Kubernetes comes with a set of primitives for that. It's called a stateful set, and you should use that. Now, a good practice around containers or microservices in the cluster and containers is around configuration management. So when you build your application to run as containers, you're actually building them as an image, like a Docker image, static image. Then the intention is that you externalize your configuration, and then when the container boot up, it boot up the image, and then it injects the configuration. Now, Kubernetes comes with two ways it can inject that in configuration, using environmental variables or using property or files on the file system. Now, there are two categories, even so, for Kubernetes. One is called config map, and the other one is called secrets. It's the same, it's a key value. Now, a config map is just any kind of key value information you want, but if you have any sensitive data, like password and certificates and other things, then you can use secrets instead. Now, Camel makes it easy, and Spring Boot and others makes it easy to access those configuration. And Spring Boot has this add value annotation. You just refer to the key using this $squiggly. And in the Camel DSL, you can use double squigglies, curly brackets to refer to the same one. Now, this is also very important practice around building your microservice in a fault-tolerant way. Camel comes with two sides here. There's the client-side retries, Camel retries, where you can use something called an exception or error handler in Camel. And the other one is around circuit breakers. And those are also quite popular in container and microservice. Camel comes with an integration with the Netflix Hystrix stack. So you use Camel Hystrix, which we're going to see in the demo. Now, when you use client-side retries, those are good for some use cases. A typical example will be around, money transfer. So if I send you $100, if that service that accepting that fails for somehow, you want your money, I can just say, nah, that don't care. I tried to call you, give you the $100, you didn't accept it, I don't care. No, I have to try again. So you can do that, and then over time in the slide here, the fourth time it works and everything is fine. Now, in that use case, you have to be a little aware. It prolongs the business transaction because I have to wait a little bit and call you again. So if there's some client that is calling me, it has to wait the full entire duration before either that succeed or fail later. And that can actually lead to another problem, known as the thundering herd problem. Now suppose that a lot of people is trying to send him $100. He would like to be a rich man, but his service cannot accept that. Then you could come under stress. And then if everybody does 3 tries calling him, it wouldn't really help. So what he needs is a little, oh, please don't call me for a while. I'll need some time off to unstress. It's like this idea of a big group of cows that comes run to you. You cannot stop them. You cannot say to the cows, please stop. No, I know. You'll just run over you. So that's the thundering herd problem. There's an alternative to this, which we're going to talk a little bit later around using circuit breakers. Now, also very important for your microservice is around health checks. So Kubernetes comes with two primitives for that, probes. One is called readiness probes, and another one is called liveness probes. There's a distinction between them, and there's a little hint. We are seeing that in the demo. But you may implement them in a similar way. But the readiness probe is used for telling the platform when it's ready when your service is ready, when others can call you. Typically, you use that during the boot up, because it may take a little while to boot up, and only when you're really ready, I'm ready. The liveness probe is used to constantly call you to check, okay, are you still alive? Are your service okay? Can others call you and whatnot? Maybe the JVM is starting to run out of memory or some other resource, and you start to crumble, and then over time you can say, no, I'm not ready. I'm not alive. And then the container knows that, and it can, mitigate that. It can, restart the process or start the container on some other node or whatever. Now, popular runtimes like Spring Boot and Wildfire and whatnot, they have health check kind of built in. Spring Boot is called actuators, and on the screen you can see Camel, just blend in with Spring Boot. So if you Camel on Spring Boot, it automatically integrates with the actuator thing, and you can see here the actuator from Spring says status up. It's sort of like the aggregated status, but you do have fine-grained details from Camel. It also says it's up and so on. What about these enterprise integration patterns, and is there any concern of using and running them in the cloud on containers? No. Those patterns were, authored 13 years ago. They are universal, so there's no problem using them. You can just go about use them in containers or traditional systems. No problem at all. There's one pattern. Here's around circuit breakers. This is how it kind of works. So it has 3 states. So in the bottom, you can see how in Camel you can use this Hystrix circuit breaker. So you just say Hystrix, and then what comes in that block is protected by this Hystrix circuit breakers. And then you can associate a fallback if you want, sort of like a try catch. And then in the catch situation, the fallback is just to do some alternative computation. Here we call it Java bean. So if calling that HTTP service fail, we call it Java bean instead. And then the state can be closed, open, and half open. So that is a little confusing, because you may think open is good and closed is bad. So, if I want to go to a bar and the bar is open, that's good. But in this situation, that's actually the reverse. And why is that? Well, it's because the circuit breaker is, comes from the real world with electricity. So you have these circuit breakers there. So if there's a spike of electricity that will otherwise go through the wires and kill all your electronics, the circuit breaker can detect that and then open. So the current can continue. You can also picture this as a bridge. You want to come with your car, the bridge is open, you cannot cross the bridge. So open and close. But you can also see from the colors, green and red, if you're not colorblind. Another pattern around containers, distributed integration, is around transaction. In a traditional way, with application servers, we had the luxury of having transaction comes out of the box with the X8 protocol and two-phase commits, so you could actually use that, but it was limited to a specific number of type of resources, JMS and JDBC. But now with containers and modern technologies, we don't have that, and there's a pattern for that called the Saga pattern, where you can sort of mitigate the transactions by having compensations or undo actions. So Camel comes with Saga out of the box, and there is an external product that has there's a specification around Saga called LRA, long run action, that is part of the microprofile effort, and there's one implementation of that currently, so you can use that with Camel. Now, the last pattern I want to talk about is around distributed tracing. So when you run your microservice in the cluster, you touch many microservices, and you don't really know which ones are invoked in that business transaction, if you will. So you need a way of being able to figure out who's calling who and how long does it take and whatnot. So that's where you need distributed tracing. It's sort of like having a little bit of breadcrumb. You pass along the different service calls so you can correlate them and then visualize that. There are 2 popular open source products, Zipkin and Open Tracing, and Camel has components for both of them. And then you can use a UI to visualize that. There's a Jaeger UI. It comes from Uber, that car company, car sharing company. So if you go back to our Decagon slide, where does Camel also come with some capabilities? So Camel certainly makes it very easy to invoke service. There are 200 components, so you can call any kind of service. Camel also has some primitives around resilience, so you can retry calling a service. This is a client-side retry, so you as a Java developer have the powers there. even so also with the Hystrix circuit breaker. Now there's also the Istio product. The Istio product also have circuit breakers, but those are not client-side, so you as a Java developer don't have any powers of that. You can configure it externally, and then Istio takes over of calling the service. So it's sort of like a mini proxy that runs together with your service. So you call Istio, and Istio calls, and then it has circuit breakers and whatnot. So you can see maybe that is becoming over time maybe a more modern and preferred way of invoking service in a more reliable way, because Istio is now generic. It's not a Java technology, so you can have all your microservices with Java, Go, Node, whatnot. Use Istio and delegate all that service invocation to Istio. And Istio comes with more and more tooling, and it becomes more a natural thing on the cluster. And some people are talking about maybe Istio comes as an easy add-on to install on Kubernetes, or maybe it comes out of the box on PaaS offerings and whatnot. So keep an eye on Istio. It's something that will matter. One note as well, on top there's a Camel REST. And so Camel also comes with a variation of the DSL. We call it the REST DSL. So you can define REST service using REST terms like get and post and put and so on. And also you can invoke other RESTful service using those terms as well. So now it's demo time. Before we go there, can anybody see that camel, what it is? Yes, it's a Lego. It's my favorite camel. It's my second favorite, or favorite camel. I'm from Denmark, Billund, or where Lego is from Denmark as well. Beautiful camel. Unfortunately, I have not seen a box of Lego where it is. Maybe I have to go to a Lego company and tell them there's so huge demand for camel. Please build a little Lego box with the camel. It'll be an awesome giveaway for talks as well. So it's a very basic example. So we just have a hello service and a client calling the service. And we're using Camel in both of them, but don't have to, but this is a Camel talk. So the client is calling that service. I don't want to click a button myself, so I just use a timer every second. I want to call the service, and then I'm protecting the calling the service using Hystrix. And if the service fails, I'll just say nobody wants to talk to me, and then I log it. On the server side of things, if you want to call it that, I'm using Wi-Fi Swarm. It comes with the HTTP server out of the box called Undertow. So it says from Undertow. And then I call a bean, a Java bean, that has a method say hello. And then I say Swarm says hello from. And then I want to return the host name. So there's a little code for that. And I'm doing that because we're going to run this in a cluster, so it's supposed to be dynamic, so we can scale up and scale down. You can see different host names, so there will be different responses. Okay, so now it is, I paid my taxes to the demo god, so let's see if he's up and awaking. So here I have already built the examples. I'll show a little bit how to do that. So if I refresh this page, I call the service, and yes, but I'm actually clicking that button if you don't believe me. Swarm says hello from, and then you can see the dynamic name is sort of like, that host name assigned by Kubernetes. Now, I can also go to a shell, and on the top shelf, I can say kube get pods. So kubectl is a command line tool from Kubernetes. There is a bit of a dispute how to pronounce it. Some say kubectl, and some say kubectl or whatever. But that's a little command line tool. Then it says get pods. So does anybody know what a pod is? Okay, so when I saw the term first time, I thought, okay, this is a process operator daemon, some sort of aberration for some computing thing. But it actually makes sense, but as a second language English speaker, it's not obvious. So Kubernetes, or how we run containers, are sort of like being popular by Docker, and Docker is the logo with the whale. So you say you run Docker containers, you run whales. So in the real world, a group of whales is called a pod of whales. So the intention is, or it actually makes sense in Kubernetes. So you run a group of containers, and that's the name pod. And the group it makes sense in the sense that it's the minimum deployment unit in Kubernetes is a pod. So in that pod, you can have 1 container, 2, 3, 4, or as many you want. Now, it's very common to only have 1. So here it says ready 1.1. So I have 1 container that is ready. But for example, with Istio, if you start to use Istio, you actually end up with 2 containers because Istio is also running a small proxy inside, side by side with your container. It's called the sidecar pattern. And that's because when Istio is in use, you call that container, and then that container called the real service. So then you have 2. But I don't run Istio, so I only have 1 and 1. Now, what I can do here is to say, okay, I'm going to follow the logs of the client Hystrix. And you can see it will, in the top screen, it will just keep on calling the service, and that's fine. And I can say here, down here, I want to delete the pod hello swarm tree. So now I'm deleting that one. And you should see up in the top, it says nobody wants to talk to me. The circuit breaker kicks in, and it does what it does. And what should happen? Well, what should happen is that Kubernetes should be able to start the pod again. And why does it do that? Well, it's because it's based on this declarative state or the happy state. So the intention with Kubernetes is that you define, okay, what is the good condition? What is the happy condition? It is, I want run 5 of those and 10 of those and 6 of those. And then you let Kubernetes orchestrate and where to schedule and run these pods or containers. You don't really care, so to speak. And then the Kubernetes platform keeps on monitoring the platform. And if something is not aligned with that happy state, it will do whatever it takes to scale up or scale down or whatever it does to make that happy again. So even though I use Kubernetes itself to delete a pod, it's deleted, but the happy state says there should be 1. And now there's 0. Then it starts 1 again. Okay, but that is not really a highly available fault-tolerant application if you only have 1 pod running. If that dies, your service fails. So why shouldn't we try to scale it up to 2 and see what happens? So when I scale it up to 2, I just use a little console here, web console, to make it a little easier because you can see the nice 1 pod here. I like that. There's a button here. You can also, of course, also do that on the web console. Now you can see up here in the top, it should start calling. Oh, yeah. Yes, it calls it, right? And then, shit, I cannot censor it. Sorry. Okay, but now it's calling those 2 services. I get a response, and then, okay, I'll then drink some water. Stop it. No. Let's see what happens. Okay. Excuse me. That was scary. Okay, now that's calling both services, right? You can see 2 different host names, kind of see these different names. And can anybody tell me what is the algorithm using? How does the load balancer in Kubernetes decide which service to call? There's only 2. Is it round robin? Is it something else? Well, okay. It is. It used to be round robin. So 2 years ago or so, it was the correct answer, but today it's actually random. So Google and the other guys, they kind of analyzed and found out that it's actually better to use random than round robin because round robin can sort of lead to a certain predictability. If you keep on the same pattern calling a service, and then maybe that can influence and make things worse. So it's actually better to just do random. But you have the choice. You can say, okay, I want to use this algorithm instead, and even implement your own. Or maybe if in the future use Istio. But that was not very fault-tolerant. I told Kubernetes, even though I used the web console, to scale from 1 to 2, and it still beep fucked up and ended up, failing. So anybody have a clue why could that be? Okay, so this is a good lesson to learn as a developer. You have to build your application in a fault-tolerant way, and errors can still happen in a big, mighty, beautiful Kubernetes cluster. Even if you tell it nicely, please scale this application from 1 to 2, and do it, please, without errors. and it still fails. Why is that? Well, it has to do with when you have a service that others need to call you, that service should only be ready when it's ready. So in that application, Java itself takes some time to boot up. And what I did not apply to that service was a readiness check. So it will just say, I'm ready immediately. And then Kubernetes start to call it, but Java and JVM itself start maybe 5-10 seconds to boot up and have the HTTP server ready. And only at that time it was ready. And if I implement readiness check on that service, it will just wait until it's ready before calling it. I will not have errors on the client side seeing. You will not see that nobody wants to talk to me. So make sure to have health checks or readiness probes in your service. But even so, if you have that, all the service could fail. Whatever can fail, you have to consider that even in this beautiful cluster, something can fail on the client side. So you have to use either circuit breakers or retries, or if an error can happen, that's okay. There's a famous use case for the circuit breaker. So Sky Sports in UK you can watch football over the internet. And sometimes there are very popular games, Liverpool, Manchester United, whatever, and people need to log in and to see the game. And maybe their login service was under stress, couldn't handle it, and then login denied. And if you do that, you get a lot of pissed, drunk English guys want to see the football game. So what they did was to protect their login service with circuit breakers, and in the future they will just say login true, and then you can see everything. Better to allow people to see the game, and it may be that some guy in the world found out, hey, that's free football. I don't pay Sky Sports, but I can see it anyway. But that's even better. That's what you want. So that's a good use case for the circuit breakers. Okay, so what I'm going to do now is go back to this. Oh, we have a little more. So just wanted to show you can also get graphical dashboard of your circuit breaker. So this is a Hystrix dashboard. And if I just quickly go here and say delete pod again. Oh, I have 2 of them now. So sorry, it's easier to see them if I only scale it to that one. And then I'll delete one of them. 3 CM. So if we go to the web console, you should see it starts to fail. 62% of the calls are failing, 85, and 100% now the circuit breaker is open, the bridge you can't cross, it says nobody wants to talk to me. Then the idea is that the circuit breaker once in a while will let a single request go through, and then check if that's okay, and then next one, okay. Now it seems to be okay, I now open it again. I go back to closed, I close the bridge, and everything is 100%. Now this circuit breaker is threshold. With Hystrix, you have a lot of parameters you can configure it, fine-tuning. Hystrix is based for the load of Netflix, so they have a high load. This is 1 request per second. This is very slow. So, of course, Netflix has a much higher load. So what I'm saying to you, if you need to configure Hystrix with these thresholds according to your needs. Your needs is likely not like Netflix. Okay, so what I'm going to do now is go to the slides, because there's more to see, more goodies. So you're supposed to read this slide, right? So this is, when you start to work with containers and Kubernetes, there's a lot of new concepts to learn, especially if you come from a traditional Java background like myself with Java App Server. We didn't only care about Java and app servers and then throw our apps to the ops guys, and it was their problem. Now there's a lot more concepts to learn. It's more native, it's more Linux, it's more networking. No, you're not supposed to read the slides, but if you download the slides afterward, you can see it. There are some terms that is just to give you an idea about storage, security, capacity management, many other things in that diagram that it's worthwhile to know a bit about. So what is the future of Camel? I just want to give you some highlights, because we're actually on the verge of kicking off Camel 3, which is going to be the next big generation of Camel. We are also working on having a new website with up-to-date documentation. I have on purpose not shown the Camel website, but if you go there, it looks like it's the Internet Archive. So if you go there, it looks like a 10-year-old website. frankly, it is. It's the first generation website, so it's very conservative. But we have on the plus of a very new modern website. There's a new logo. I wear a t-shirt with that. Camel 2.23 is probably the last 2x release. We are aiming for November, Spring Boot 2.1 support and so on, and then Camel 3, yes. So some highlights of Camel 3 is that we are working on making Camel run on Graal VM, at least Camel Core on some of the components. There's a prototype we have here is able to boot up Camel and start it in 1 millisecond. Even run with some routes defined in JavaScript. And there's a new sub-product we just announced 5 days ago, Apache Camel K. So Camel K is a lightweight integration framework that is aimed for running natively on Kubernetes in more of this, you can say, a serverless and microservice architecture. The idea of Camel K, or how it kind of works, is that you, as a user, you don't care so much. You just write your integration code in Java, JavaScript, Kotlin, whatever. Then there's a command line tool or other tools that are able to materialize that and deploy it in the container. And there is something called an operator running in the container, which is sort of like that smart thing that monitors something called a Kubernetes custom resources. This is where your integration code lives, and then it can quickly spin up and run containers with that. And let's just go a quick demo for that before I am kicked out. So I will just say, go here. And here I have Camel with there's nothing running. Oh, there's actually something running, so let me just delete that. So here, I have a Java file. It's from a timer and call a setBody with a constant and logging it. So over here it says hello camel. So let's just run that one. Okay, this is the other one, sample. So I run that one from the command line in dev mode. Dev mode means it will show the logs on the console, and you can see it's actually already booting now. It says hello camel, camel rocks. And if I go here and say, I just say bye camel, something like that, save the file, and then it redeploys, and now you have bye camel. Okay, that's fine. Let's just go for another thing. You can also write in JavaScript. So this is a JavaScript that uses a DNS component, Camel, to get the IP address of Google. So just quickly run the DNS. Sorry, I have to change that. DNS.JavaScript. And now it spins up that container. And you can get the IP address here is .36. If I change it to Yahoo, and save it, and it should be the same thing again. It redeploys, and so you get this quickly redeployment thing, and it can include other dependencies on the class part and whatnot, and build containers for that. But when it has a container for it, it has everything it needs at runtime. So it's very quickly just to modify your source code and whatnot. And just imagine if you have Graal VM and whatnot, and even lighter Camel, it can become even quicker. So we go back to the slides, and there is less and less time. So free books, people like that. There is a free book about if you were building microservices for Java. One about Istio. And there is also a book that's not so free, but it's good about Kubernetes. Istio is is currently being written. And that's also my book. This is the best book. I can give you a discount code, Camel39, if you order it from the Manning website. Sometimes they give a bigger discount, like 50% or so you can try to find that code, Camel 99, 98, 97, and so on. But I have even better. I have 30 copies for free, which will happen as a book signing out there in that book, that table at 3:20. And the book also gives you a free electronic copy, so you can get both of them. And I will be there with Mr. Camel. So more information, where can you find the slides, is on my GitHub account in a project called Camel Writers in the Cloud. There's a branch for each different talks I've done. And we are for Q&A, just 1 minute or so. overtime almost. I will be around. You can also catch me on the hallways and ask questions around Camel and whatnot. Is it lunchtime now, so you want to go there? Yes. Okay, so thank you.